Alright, so in this video I'm going to be interpreting displacement time graphs. Now you really need to be comfortable looking at these graphs and understanding what it means. So all of these are going to be displacement time. So time on the x-axis, displacement on the y-axis. So the first graph here, time, distance. Now here's our origin. Now this means that A started a distance away from the origin, in front of the origin, and A is moving towards the origin. Now it reaches the origin here at whatever that time is. Now B started further back, or sorry, started further forward, further in front. So if this was the number 4, A is starting 4 meters ahead. If this is B, number 8, B is starting 8 meters ahead, and it's moving backwards. Now notice the gradients look the same here. That means that they're traveling at exactly the same speed. So the origin is back here somewhere. This is A, this is B, and they move back like that. Okay, here we have A, B, and C. Now B's an interesting one. Let's start with B. B starts some distance away from the origin, say at a distance of 7 meters away from the origin, and it stays 7 meters away from the origin. A flat line like this in a displacement time graphs means I'm not moving. I'm stationary for some amount of time. A has a quite steep gradient, while C has like a less steep gradient. They've both started at the origin, at the start point, at the starting position, at the start of the race. A is moving faster than C. Now, they're straight lines, which means the velocity is constant. They're moving at a constant speed, but A's velocity is greater. Alright, so here's an object here. You can see it's starting a little bit ahead of the origin, in front of, say 2 meters in front of. I'm just making up numbers here, but just some number in front of. It's moving away at a constant speed because it's a straight line, and then it's moving back towards the origin. If it goes a little further, it'll get back to its starting position. Now that's a pretty quick change. Boom, boom, like it's a quick turnaround like that. Alright, this fourth example here, two things starting at the origin, A and B. B moves at a constant speed away from the origin quite slowly. A moves at a faster speed away from the origin, and then abruptly stops. Just stops and waits on the spot. Okay, so you can imagine two people, they leave, one's faster than the other, but they get to a finish line, at which point the fast one needs to wait. So flat lines always mean waiting, always mean stationary. So if we look at this one, B started some distance away from the origin and waited and waited and waited and waited and waited and then started moving back towards the origin, whereas A started further back and started moving towards the origin at a constant velocity, at a stationary, constant velocity. Okay, and then finally this graph here, A's moving quick, B's moving slow. B's moving quick, A's moving fast. A's moving slow. So, high gradient, fast, low gradient, slow. Alright, you really want to become very, very comfortable with these displacement time graphs. Maybe take a break and then come back to these pictures and see if you can come up with the same interpretations that are written there. There's also some questions in your textbook that do identical sorts of ask you to interpret these graphs.